You know, that feeling, that kind of nagging urge to know more, even when there's maybe no clear reason why, that deep pull towards a new idea or some hidden connection. Today on the deep dive, we're really peeling back the layers on that very human impulse, curiosity. We're going to try and uncover what it truly is, how it fuels innovation, and, get this, how it literally rewires your brain. We pulled together insights from a podcast with the senior trainer at rover.com, a scientific review on curiosity and creativity from UCSB, and some really deep dives into the neuroscience of dopamine and neuroplasticity. Our mission, to arm you with some surprising facts and hopefully some practical takeaways about this incredible, often underestimated drive.
Yeah, and what's truly fascinating here is how often curiosity is just sort of simplified or maybe even overlooked. But these sources, they reveal it as this really complex, dynamic state. It has profound implications for how we learn, how we innovate, and even, how we maintain brain health throughout our entire lives. We're going to try and connect the dots today, from individual motivation all the way to organizational culture and right down to the chemical reactions happening in your brain. Well, probably right now.
Okay, so let's start by maybe shaking up some common assumptions.
Yeah.
We hear curiosity and innovation thrown around a lot, especially at work. I almost feel like buzzwords sometimes. But what are maybe the less obvious truths hidden in how we should define them, and how do they actually connect?
Well, Bethany Klein, she's a senior trainer from rover.com. She offers a really insightful perspective here. She starts with the standard Merriam-Webster definition for curiosity, a strong desire to know or learn something new that you didn't know before. Pretty straightforward. But what she adds is crucial. She says it's not just about seeking information. It's about the active behaviors that follow. Things like asking questions and critically active listening to understand, not just waiting for your turn to talk. It's about really internalizing that new knowledge.
That distinction alone feels like a bit of a game changer, doesn't it? It's not passive. And what about innovation then? Because I think many of us, when we hear that word, we immediately imagine some huge world-altering breakthrough.
Right. And that's where her insight is really interesting. Klein defines innovation not as some grand revolutionary invention, but simply as picking up a new method, idea, or process that's new to you. So you don't have to be inventing the next iPhone, If it's a new strategy for your team to manage projects maybe, or a more efficient way for your organization to handle some task, that counts. It kind of democratizes the whole concept, really. And for her, curiosity naturally leads to this kind of innovation, which in turn drives competitiveness, efficiency, quality for an organization. It can be a small change that saves 5 minutes or, a large one that transforms a whole department.
Okay, this brings us to a really fundamental question, one that I think leaders and educators grapple with a lot. Are we just born curious? Or is it something we can actively cultivate, in ourselves and maybe in our teams? Because for anyone looking to foster a more innovative environment, this feels pretty critical.
Klein's perspective, and this is supported by a broader understanding of human development, is that we are all fundamentally naturally curious. I mean, think about a baby just exploring everything around them, right? The real barriers aren't usually a lack of innate curiosity itself, but more often organizational limitations, things that get in the way. These could be cultural, like people not feeling safe enough to share new ideas or challenge the way things have always been done. Or they could be process barriers, where implementing even a small new idea is just too difficult, too bureaucratic. Even just simple time constraints can effectively stifle what's already there. So her argument is, if you remove these barriers, people will naturally be curious.
So it's less about trying to instill something new from scratch and more about unleashing what's already there, maybe just lying dormant, waiting to be expressed. But then she also mentions it can be trained. How do those two ideas fit together?
Exactly. It's about unlocking potential that's already present. And yes, absolutely. Just like you can train leadership skills, the behaviors of curiosity, things like actively asking probing questions, seeking out diverse learning experiences, or even just observing things with fresh eyes, those can absolutely be trained. But her core proposition is really about creating the conditions where curiosity can flourish. Remove the roadblocks first, and that inherent drive will naturally spark and find expression. It's kind of a powerful combination, removing barriers for that innate curiosity, and then maybe training the specific skills to harness it effectively.
Okay, so for someone listening, maybe they're in an organization that feels a bit stiff or, buttoned up. What's the very first, almost stealth move they could make? Something small to start chipping away at those barriers and foster more curiosity without, turning everything upside down overnight.
Her advice is classic change management, really. Start micro. Think small, achievable behaviors that can build on existing routines. She shared this brilliant example from her own team meetings. They started each weekly sync with a strict 5-minute segment, just 5 minutes, where a different team member shared something new they learned that week. The constraints were super simple, 5 minutes max, and it had to be something actionable or maybe a helpful resource someone else could use. They even kept a running, living document of these shared learnings. It took minimal effort, right? But it subtly encouraged active learning and sharing without adding this huge burden or feeling like a major new initiative.
I can totally see how that small shift could build some real momentum. Did the sources mention any common pitfalls or challenges in keeping something like that going? And then how do you scale it up into something bigger?
Yeah, a couple of things. One challenge is just consistency, making sure it actually happens every week and doesn't get pushed aside when things get busy. Another is ensuring it feels like a safe space for all kinds of learnings, not just the big successes, but maybe things that didn't work too. As for scaling, in her case, that initial 5-minute sharing organically grew into a learning discussion group, sort of like a community of practice. They pick topics they were collectively curious about, maybe agree on listening to a podcast or reading an article, and then just discuss them. No formal learning objectives, just sharing those aha moments. For instance, she mentioned discussing a podcast on negotiation skills led to these unexpected connections that were applicable to their daily work, things they hadn't anticipated. So the scaling involves growing these small initiatives, maybe leveraging existing frameworks like mentoring groups or even informal book clubs, while always being really mindful of time and money constraints to make sure it's sustainable.
Right, sustainability is key. Okay, we've talked about how curiosity drives innovation in the workplace and how it can be fostered in teams. But what's actually happening inside our heads when we feel that pull to learn? Let's zoom in a bit on the brain's role, especially linking curiosity to creativity. The UCSB source highlights that while the theory connecting them is strong, the actual empirical evidence has been, maybe surprisingly, a bit scarce until recently.
Indeed, theoretically, it makes perfect sense, right? Both curiosity and creativity thrive on novelty. Curiosity involves actively pursuing new knowledge, while creativity often involves transforming existing knowledge into something novel, maybe by making surprising connections. And recent studies are finally starting to show those empirical links more clearly. We're seeing individual differences in curiosity correlating with how creative people perceive themselves to be and their tendency towards innovation. Even subtle things like how our eyes move when exploring something new show a correlation with both curiosity and creativity.
Wow, so it's not just this abstract feeling inside. It's something that's actually observable in our behavior, even down to how our eyes literally scan a scene.
Precisely. And the research gets even more granular than that. It differentiates between different types of curiosity. There's epistemic curiosity, that's the thirst for knowledge, like wanting to understand a complex scientific theory. Then there's perceptual curiosity, which is more about seeking out new sensory experiences. Think about why you might try a strange new food or explore an unfamiliar soundscape. Both of these types are linked to creative behaviors. And they get even more nuanced. They talk about diversive curiosity, that's the broad exploratory interest, like endlessly browsing different topics online. This predicts early information seeking and can help with creative problem solving by bringing in diverse ideas. Then there's specific curiosity, which is about filling a very precise knowledge gap, like when you just have to know the answer to a specific trivia question. That specific type is crucial when deep expertise is needed, promoting creativity through what they call idea linking, a more sequential exploration of related concepts.
Okay, that makes sense. Different kinds of curiosity for different kinds of creative tasks. And how does the brain itself actually facilitate this relationship between seeking new information and generating new ideas? It's all just about, consuming more information.
Not entirely, no. What's really fascinating here is that the mechanisms linking them include not just those exploratory tendencies and complex information seeking we talked about, but also something called a wide scope of attention. Essentially, your brain becomes temporarily less selective about what information it filters out. You could think of it like opening up your mental floodgates a bit wider, which actually aligns with how many creative breakthroughs happen, right? By connecting seemingly disparate ideas that you might otherwise ignore or filter out. This wider scope allows for more sustained engagement with unfamiliar ideas, potentially leading to more original discoveries. Now, it's true, a major methodological limitation historically has been the lack of experimental studies. Most research was correlational, but the good news is that new behavioral measures are emerging now. Things like the effort task, where people literally have to exert effort, like press buttons, to gain information. This gives a much more dynamic assessment than just asking people how curious they feel on a survey.
Okay, let's dive even deeper then, right into the brain's internal workings. We often hear about dopamine, the feel-good chemical. But what's truly compelling is how our sources reveal it as almost the engine of curiosity itself. What role does this neurotransmitter actually play in our desire to know?
Oh, it's absolutely central. Dopamine is the neurochemical that boosts mood, sure, but also motivation and attention. Critically, it's what causes you to want, to desire, to seek out, and to search. It literally increases your general level of arousal and your goal-directed behavior. When your brain releases dopamine, it activates what's called the reward circuit. This circuit registers intense experiences as important and helps create lasting memories, compelling you to repeat those behaviors. So that feeling of needing to know, or that sense of pulling on a thread when you're learning something new, that's dopamine, fueling your search for information and making you intensely curious about new ideas.
So if you're someone who feels a really strong pull towards novelty, always seeking out new experiences, does that mean you might have naturally higher levels of dopamine activity?
Well, yes, a person with high levels of dopamine activity can often be described as a sensation seeker or having high novelty-seeking traits. They tend to see potential stressors more as challenges to be overcome rather than threats to be avoided. And interestingly, this tends to build hardiness and resilience over time. It makes sense, right? If your brain is fundamentally geared towards seeking and reward, you're probably less likely to be deterred by uncertainty or difficulty. But this raises a really important question. How does this wanting system, this dopamine-driven seeking, translate into better memory? Because that's a huge potential benefit for anyone looking to learn more effectively.
That's a fantastic question. And the PubMed Central source introduces this framework called PACE prediction, appraisal, curiosity, and exploration. Can you break down how this cycle explains curiosity's power in actually improving learning and retention?
Absolutely. The PACE framework lays out this really fascinating cycle for how curiosity enhances learning and locks in memories. First, P is for prediction errors. This is the trigger. Curiosity sparks when something unexpected happens, when reality doesn't match your prediction. These can be context-based errors like arriving in a completely new place, your hippocampus is going wild, or they can be information-based errors. These information gaps are moments of cognitive conflict. That's when your anterior cingulate cortex, which acts like your brain's internal error detector, flags something that doesn't quite fit. Okay, then A is for appraisal. This is a really crucial fork in the road. Your lateral prefrontal cortex evaluates the situation. Can you cope with this uncertainty? If you feel capable of resolving it, maybe you hear a strange sound and think, that sounds like a cork popping. I wonder what's going on. And you feel an urge to investigate. That appraisal sparks curiosity and leads to exploration. But if you feel overwhelmed by the uncertainty, maybe you hear that same sound but interpret it as a gunshot and feel you need to flee. That appraisal might lead to anxiety instead of curiosity. Next, C is for curiosity and dopamine. If that appraisal leads down the curiosity path, your lateral prefrontal cortex stimulates the midbrain, specifically key areas like the substantia nigra and ventral tegmental area, which are the main production centers for dopamine. This dopaminergic boost directly enhances that exploratory behavior and the drive to seek information. And finally, E is for exploration and critically enhanced memory. This heightened state of curiosity increases your attentional bias. You focus more intently on the new information you're seeking. And here's the truly powerful part. The dopamine surge then helps both encode the new memories related to your exploration and, crucially, helps consolidate them into long-term storage. What's amazing, and this is key, is that this memory boost applies even to incidental information encountered while you're in that curious state. So it's not just the answer to the trivia question you were curious about, but maybe even an unrelated face shown alongside it will be better remembered later. It sort of spills over.
Wow. Okay, so if I'm really curious about, say, a new recipe, and while I'm looking it up, I happen to stumble upon an interesting cooking technique I wasn't even looking for, my brain is actually more likely to remember that technique later, just because I was in that curious state. That's incredible for learning. It really makes you think about all those times you've gone down some unexpected rabbit hole online, right? That's our dopamine, pulling us along and enhancing memory as it goes. So is there anything practical we can do then to maybe naturally boost our dopamine levels and, by extension, harness this curiosity-driven learning more effectively?
Absolutely. And it often comes down to simple foundational self-care because that supports your brain's natural chemistry. The sources mention things like consuming foods rich in tyrosine and magnesium, think things like cheese, lean meats, nuts, legumes. Also, trying to avoid excessive processed foods, sugar, and caffeine. Prioritizing proper sleep hygiene is huge, getting regular daily exercise, and managing stress through techniques like mindfulness or meditation All of these basic health behaviors support natural dopamine production and regulation, which in turn feeds right into this powerful pace cycle, leading to better attention, motivation, memory, and ultimately better knowledge acquisition. It's really a holistic approach to keeping your brain primed and ready for curiosity.
This whole deep dive has really shown how curiosity helps us learn and innovate, really at any age.
Yeah.
But it sounds like it's not just something for adults optimizing their work or learning. How does this fundamental drive manifest in children? And how does it relate to our brain's incredible ability to change throughout life, what we call neuroplasticity?
Oh, from the very beginning, from infancy, curiosity is absolutely central. Babies, for instance, face this tremendous sampling problem. I mean, how do they possibly choose what information to focus on from this overwhelming world around them? They seem to have some innate biases, like being drawn to high contrast images or human faces. But what's interesting is that over time, their interest isn't just in pure novelty, but in stimuli that are partially but not fully encoded into their memory already. It's often described as the Goldilocks effect. They seem to prefer things that are just right in terms of complexity, neither too simple and boring, nor too complex and overwhelming, because that just right zone is where optimal learning tends to occur. They seem to implicitly direct their attention to maintain these sort of intermediate rates of information absorption.
Huh. So children aren't just like passively soaking things up like little sponges. They're actively, maybe even unconsciously, curating their own learning experiences based on their curiosity and what feels optimally challenging. That makes a lot of sense, actually.
Exactly. And as they grow, children's play isn't just fun and games. It's actually a very sophisticated way for them to reduce uncertainty and discover the causal structures of the world around them, how things work. Studies show they'll even preferentially play with toys that violate their expectations, things that surprise them, or toys that allow them to systematically deconfound variables, like figuring out which specific block makes a machine light up. This is basically hypothesis testing in action, driven entirely by curiosity, even at a very young age.
And how does all this active engagement, this curiosity-driven exploration from childhood onwards, tie into the concept of neuroplasticity?
Well, neuroplasticity is the brain's truly incredible ability to change and adapt throughout our entire lives as a result of experience. It can reorganize pathways, create entirely new connections between neurons, and even, in some brain regions, generate new neurons. This is absolutely fundamental to all learning and memory. When we engage our curiosity, we are directly stimulating this neuroplastic process. Whether we're talking about functional plasticity, where the brain might reassign functions from a damaged area to an undamaged one, or structural plasticity, where learning literally changes the physical structure of the brain, like thickening certain cortical areas. Curiosity is a powerful driver, actively engaging with novelty, maintaining focused attention, tackling mental challenges. All things that curiosity encourages directly stimulate these positive, adaptive brain changes.
So by consciously choosing to nurture our curiosity, by staying open to new things, we're essentially keeping our brains not just active, but more fit, more agile, and adaptable across our entire lifespan.
Precisely. The sources really reinforce that while young brains are incredibly plastic, adult brains absolutely continue to adapt and change significantly based on experience. It doesn't just stop. To improve neuroplasticity at any age, the advice often includes enriching your environment, learning new things like a language or a musical instrument, traveling, creating art, things that challenge your brain in novel ways. But also those fundamental things we mentioned earlier.
That's right.
Proper sleep hygiene, regular physical exercise, which is known to prevent neuron loss in the hippocampus and even promote the formation of new neurons there, and practicing mindfulness or meditation. All these actions, which are often fueled by an underlying curiosity to learn or improve, directly support your brain's inherent ability to change, grow, and thrive, helping you stay sharper for longer.
So after all this, what does it really mean for you listening right now? Today, we've gone from unpacking curiosity and innovation in the workplace, all the way to exploring the intricate neural pathways, the dopamine rushes that power our deepest desire to know. We've seen how curiosity isn't just a personality trait, but a fundamental drive, shaping our learning from infancy right through adulthood, and how it directly impacts our brain's incredible ability to adapt and grow.
Which really leads to a final provocative question for you to think about. If curiosity truly is this potent superpower for learning and innovation, how can you consciously, intentionally cultivate it further in your own daily life? Could deliberately seeking out new information that's just slightly beyond your current understanding, what the researchers call optimally discrepant information, whether it's in your professional field or a completely new area, could that be the key to unlocking even more of your brain's incredible lifelong potential for growth and insight?